All right, we're going to be doing bisectors of a triangle, section 5.2. We just learned what an angle bisector did. We just learned what a perpendicular bisector did. And so now we're going to use that with a triangle and see how it relates. Okay. There's some vocabulary. These vocabulary words are on your term sheet. This is one of the very few times that I'm letting you put terms or vocabulary inside your postulate book. Anything that's on this term sheet you may write in your postulate book. So locate them as we go. We're going to draw them on our sheets as we go. The very first one is concurrent lines. You have it written in there what a concurrent line is. So if you'll get your term sheet out so we can read it together. Concurrent lines are three or more lines that intersect at a common point. If we draw that, I have one line here, another line here. How can two lines be concurrent?
Three or more.
It has to be three or more. Now, because two lines, if they intersect, they automatically form in one point. It would be, if I had another line, let's say a blue one, are those concurrent? Why?
Because they don't all three intersect.
They don't intersect at a common point. So I would have to come through like that. And then I would have concurrent lines. Here's a drawing for you to put in your book. This one drawing will also be for the next one. So you'll share concurrent lines. Actually, yeah, for the next one. So you can use that drawing for the next one also. What is the next one down from you on yours?
Point of concurrency.
Point of concurrency. So we have point of concurrency. The point of concurrency is the point of intersection of concurrent lines. So I had that drawing a moment ago, right here. The point of concurrency is just right there.
Wait, is this number 5?
I think you just did number 5 and 6. We have concurrent lines. These are concurrent lines because they meet at one point. And that point where they meet is the point of concurrency. Right? I shouldn't do red. Do yellow. Your point of concurrency. I got a humongous point. All right. Inscribe. Is that the next one down, or is it down a little further? Inscribe is number 12, by the way, number 12. What is the word scribe? Does anybody know what scribe means?
Right.
To write, okay? If something is inscribed, it's written inside something, okay? So a polygon is inscribed in a circle if each of the vertices lies on the circle. So if I have a circle, I actually can draw a circle. That's so cool. As long as I get it to be a circle. All right, so I have a circle there. And is this triangle inscribed?
No.
Because?
Not all of the corners are on the circle.
That's correct. Not all of the corners are on the circle. So I have to have all of the corners on the circle for it to be inscribed. That one you have right there, that's true. We have an inscribed circle. Inscribed triangle. Yes. Is this an inscribed triangle?
No.
What's inscribed on this one?
The
circle is inscribed on this one. That's correct.
Okay, so what do we do with
So
these?
it wouldn't be inscribed though because the vertices have to lie on a circle. The vertices of a polygon have to lie on a circle. So
We'll talk about that one in a yes. If something is if I do this, yeah. Yeah, to be inscribed, it just has to touch on all sides.
Oh, okay.
Okay. This one, we have inscribed here for an inscribed polygon. But if I would have had, let's go back. If I would have had my triangle out here, it would not have been,
Correct.
the circle is not inscribed. It's just surrounded. Next vocabulary word is circumscribed. this first here, this means outside, the circum. And then scribe means written, so it's written on the outside.
Oh.
So if you have a circumscribed circle, it's the circle that contains the vertices of an inscribed polygon. So the same picture I had earlier. And then my triangle that I had.
So what's the difference?
Which, the circle is the circumscribed circle, and the triangle is the inscribed triangle. Okay? Just depends on which one I'm talking about. The circle is circumscribed, the triangle is inscribed. So you have a diagram, we can turn it around with your little things you're going to use folding it a little bit. One's inside, one's outside. The inside one's the inscribed, the outside one's circumscribed. So you can have the same picture for both, just pointing to different things. Where are those in relation to each other on the...
Far apart.
So when you draw them, you can, when you write them in your postulate book, you can put them together. You can put them right. The order doesn't matter when you put them in. All right. Questions about all these? Lots of vocabulary. Okay.
Are these just the vocabulary for 5? Are we going to get new one for 6?
You'll get new vocabulary for
6.
chapter 6. Yes. Yes. All right. So you have a piece of paper that looks like this one right here, and I do too, so I can fold it all together. Yes, I did. Okay. Each person has a paper triangle with a circle around it. Okay. What's inscribed and what's circumscribed? So what's inscribed?
The triangle.
And what's circumscribed?
Circle.
The circle. Okay. We're going to fold this according to the my instructions. Here's the first instruction. We're going to fold it to form the perpendicular bisector of the sides. All right, so this is what we're going to do, is we're going to take this corner and fold it on top so that, you might even have to put it up to the light, so that the lines exactly fall on top of each other, and so that those bottom lines fall right on top of each other.
Wait, which
So if you
The
need to
side
put
lines aren't going to.
that's correct. This is not
Oh, okay.
isosceles. Only this bottom line here. I'll draw it on here. Only this.
the long one? Because the
Sure.
long one's the one
It
that's
won't matter
not-
which one. We're going to do it to all of them. So only this one will be on top of itself. The rest of them will not. You need to put it up to the light to make sure it's on top of itself. And
So
then
does it matter which side we're doing right now?
It does not matter. We're going to do all 3 of them anyway.
Oh, yeah.
If you need help, Brett, ask Josie. She's really good at this. And then make a crease.
Yeah, I have that.
And if it's easier at that point, you can come make your line dark, like with a straight edge. All right, we have just done the perpendicular bisector. We folded it in half, and it made it. We have just done the perpendicular bisector. All right, turn it over and do the same thing on the other 2. If you need to put it up to the light so you can see.
Which way you folded it now?
On a different
Right,
side.
which one did you
Same
Turn it to
side.
the next side
You
now.
have to do all 3 sides. So
All 3
she
sides.
just did this one to this one, right?
Yeah.
So now you have to do this one to this one.
I
Okay.
personally like to make mine a little darker so I can see.
It really helps if you hold it up to the light.
Yes, it does. You see, it
I'm too lazy
glows
to do
through
that.
it.
Too lazy to do that.
But I have to like put my arm up and everything.
All right, after you're done, you should have
A star.
a picture, something that looks similar to this. All right? You folded it. You've got a point there. You just made 3 points. Did your 3 points? We just had 3 lines. Did your 3 lines
Yeah.
come to 1 point? So those lines are called what kind of lines?
Congruent.
Very good. So you have, and if I mark something right there, I am marking the what right there? What did I just mark? The point of concurrency. What did you just find on all those? You found the perpendicular bisector, correct? All right. I'm telling you right now, you just found the center of that circle.
Oh, sweet.
Okay? You just found the center of that circle. You found the center of the circumscribed circle by finding the perpendicular bisector of all of the sides. On your homework, if you're given a triangle and asked to find the center of the circumscribed circle, you can't fold it. You're going to have to use the construction to find the perpendicular bisectors of all those sides. Okay?
Wow.
We're going to do one together. You'll find out. Okay? All right?
What if
All right.
we cut the circle out?
That would be so nice.
They won't have a circle on it, but if you cut this, I would think that since it says the instructions will say construction, you'll have to use your compass and protractor, but...
Oh, I don't have
Yeah.
a compass. Yes.
All right, they did come to the same point. I'm going to tell you that we marked that point of concurrency. It's the center of the circumscribed circle, and it has a vocabulary word. It is called the circumcenter. So if I was you, you're going to glue this to the back of your little yellow thing. I would write on it circumcenter. It is the center of the circumscribed circle. That's why it's called the circumcenter.
I have a question.
Yes, sir.
If we're gonna glue this to the back of here, why would we put it on the back?
No, don't write it on the
Why
back.
would
No,
we
I
write
didn't.
it on the back?
Don't write it on the back. Write it on the front. And then you glue it to the back.
And then you
Okay.
Did I
I
answer
thought
your
you were
question?
saying right on the back.
No, don't
That's
write
why
it
I
on the
was
back. Yeah,
like,
that's that. If I said that, then I apologize. But I can play back this video to find out. This is called the circumcenter.
The middle or the whole thing?
That point that you wrote, that point right there, is called the circumcenter. Yes.
That isn't gonna
It is the center of the circumscribed circle. The trick is you have to remember, for me it's easy to remember that the circumcenter is the center of the circumscribed circle. But how did you find it? You found it with the perpendicular bisectors. And so that's going to be the trick. And by the way, make sure you leave space for your other one, Ryan. When you put it on, you're going to have two things. So put it kind of onto the side, make sure. Okay?
Oh.
You go and glue it to the back of your, yeah, go ahead. Yep, that works.
Okay.
All right?
Now I wanna know what the front's for.
That's what we're going to do now. Very good question, Amy. We're going to go to this section right here.
Oh.
All right?
Okay.
I'll wait though because we're still gluing.
Oh.
All right, we're going to recap what you just did. We have the word circumcenter on your note sheet. It's the very first one on the left. You have your triangles. You have some triangles there. You need to find the perpendicular bisector of the sides. You have two of them. Which one do you think is the perpendicular bisector of the sides if you go and look at those triangles?
This?
Yes. Which one of those shows the perpendicular bisector of the sides on your two little blue triangles here? Which one of those?
Aren't they the same?
And they're not. They should be. One shows something
they're
perpendicular.
close, but not quite.
Yeah, true.
Yeah, one shows something happening to the sides, one shows something happening to the angles. We just did perpendicular bisector of the sides.
So we want
Oh,
the
so
one
it's
with
gonna
sides.
be the one with the, it's gonna be this
What letter does it have on the back?
one. Oh, or.
It should have a D on the back of it. It should have a D on the back of it. Go ahead and glue that one here. And we're going to...
Ah, sorry.
Oh,
It's okay.
Yeah, I thought that was
It might be my handwriting because I actually did one too. So,
But I was right.
and I'm going to actually fix it because I don't like it as well. I think we should extend those lines out because I think those lines
Not a
should...
B, Amy, a D.
Yeah, let me show you. I'm going to just show you on Josie's real quick. If I were
know.
you,
That's,
I would
erasing
take a
this
ruler
one.
and I'd come up and I'd go, just because I think it would make you understand what happened there. That these
I
go,
want it to be
these keep
capital D,
going.
But it won't.
That one does, and that one,
Yeah.
it kind of, I don't know why it curves. I don't know why would they do. You found the perpendicular bisector of the sides is what you did. So that circumcenter, we're going to fill in the rest of this based on our, oh wait, you guys are still gluing. I'm trying to get ahead of myself.
Wait, do we have to glue these on?
It goes right,
Where does this go?
it goes, I'll show you. You have your little triangle here,
Wait, so there's no.
and you have a perpendicular bisector of that side, a perpendicular bisector of this side, and a perpendicular bisector of that side. They should all come to a point of concurrency in the middle. They'll be glued right there. How was the circumcenter created? You have a, what kind of bisectors?
Perpendicular bisector.
Perpendicular bisector. So right here in this little piece, you're going to write perpendicular bisector. If you want to abbreviate, you want to write the whole word perpendicular bisectors, it's up to you.
Is it bisector or bisectors?
Sure. You have to have 3 of them to make a point of concurrency.
Oh, yeah.
So we'd have to have all 3, yes. Now you have a theorem about the circumcenter. It's called, your theorem is called the circumcenter theorem. If you'll look there, I don't know, remember what number it is. Anybody?
Number 9.
Number 9. Number 9, if, Naraya, since you found it, will you read it to us?
The circumcenter of a triangle is equidistant from the vertices of the triangle.
All right. So right here, the circumcenter of a triangle is what? From the what of a triangle?
Is equidistant from the vertices.
From the vertices. We're going to talk about that. Oh, I now know why they put all those on there. I know now. What was I thinking? That part that I said, I don't know why they put those there. I know now. Crazy. Okay, I'll draw it in a minute. Crazy. So what word goes here? Ooh, doesn't fit. Equidistant from the vertices. That's the corners, right? Okay, so it's also the center of the it's the center of the circumscribed circle. So that's why they put them there. I'm going to do it in a different color. This line here in purple, and this line here, and this line here are all, those purple lines that I just drew are the same length. If I was to take my compass and open it up along this point and this point, I could draw a circle. From here over to there, it would be the same distance. Put my right there at the center, and I could draw a circle all the way around. Are you with me so far? Okay. In a moment, we're going to do a different one. I'm going to give you something to help you remember this. I would suggest that you put it somewhere like down here. What you did was you bisected the sides. If, this is like an if-then statement. If you bisect the sides, then, you could fill in the little blank, circumcenter, is equal to the angles.
What?
Okay? You bisected the sides, so you found a point that was equidistant from all the angles or the vertices. Okay? I will be giving you another one of these in a moment, and it'll maybe a little click in a minute why this was going to help you. If you bisect the sides, you get a point that's equidistant to the angles. And that's kind of a little shorthand, bisect sides, then equal angles. Equal to angles. If you want to put another word in there, distant, you could, equidistant. That's what that equal is supposed to stand for, is equidistant.
But so the equal sign is equidistant?
Yes, this right here stands for, if you bisect the sides, then the point is equidistant from the angles. Okay? Let's do another paper folding thing. You have this one right here. I do too.
Are we just doing 2 of these today?
Yes, that's correct. All right, so let's see what happens when we bisect all the angles of the triangle. Before we start, what's inscribed and what's circumscribed?
It's
The circle?
The circle is inscribed, and the triangle is circumscribed. Because it's the in.
I thought the circumscribed can only be a circle.
That's a good point. It looked like that when on our definition, but the word inscribed means it's inside and it's touching the edges. That they're still touching. The one that's on the inside is inscribed. The one that's on the outside is circumscribed. Okay. All right. So we're going to fold this. You're going to now take. I have these 2, and we're going to take it so that the 2 sides fold so that we can go clear up, make the fold go along that point right there. We're going to bisect the angles. Last time we perpendicular bisected the sides. So we're laying these 2 on top of each other so that we can get that on there. I'm going to pause this and come back when we got it.
Glue it to the back.
Yes, yes. So we just folded all the angles in half. I'm going to take a picture and bring it
I did
in.
this correct.
You
Do we
did.
still have to save room for other ones?
I'm sorry.
Yes.
No.
If you did it right, It should look similar to this one. Actually, your guys' looks better
It
than
should be the
mine.
center of the circle.
You see, your guys' should have a point of concurrency. I made mine look little on the screen here because it and put a dot there because mine wasn't as perfect as yours. I don't know if you guys can see as well. I'll take that off. But I have a little teeny triangle because it didn't come exactly, but that's okay.
Mine came really close, but
It
not
should-
quite.
Okay, so you have 3 lines. They all met at one point, so those lines are called what?
What?
Wait, say that again, please.
Those 3 lines met at one point, so those lines are?
Oh.
Concurrent lines.
They are concurrent lines. That red dot that I just drew.
Do I have to put more than one? So can I just do they need to be close to each other?
No. Put them all. There's no more that's going to go in the back that I know of. If there is, we'll make room for some.
Well, I have plenty of room, so.
So that dot is called the what?
Concurrency.
That dot is the center of the inscribed circle. You just found the center of that inscribed circle. That means, I'm going to draw here, that this distance from out to here, out to the edge of that circle, out to the edge of the circle here and here, is the same
So then
distance.
technically wouldn't it be the center of the triangle?
It is the center of the triangle.
Did we need
And the
to
circle?
draw the?
These are all different kind of centers to the triangle. The last one was the circumcenter. It's the center of all of the vertices. This is the in-center. It's called the in-center. And it's the center of all the sides. Okay? These things that I just drew here are perpendicular, by the way.
Oh, what? Oh, cool.
Not the ones that you, but the new ones that I, yep, they
Oh,
should be
they're
perpendicular. Mm-hmm.
Do you have to draw the extra line?
You don't have to draw the extra lines. You have a drawing of it on that blue little triangle that you're going to put on the next side. So go
Okay.
ahead and turn over the piece of paper.
I'm
You
trying to
should
see
have.
which way you have your triangle. Oh, that's how.
My bad. Did you go back?
Question.
No, I was just questioning.
Yes.
Yeah, you only have 3 lines on there. Did I need to? Just...
I
Yeah,
have.
I have 6.
I have.
Well, what she did?
If
She
you look
did
right
all the
here,
way
I
through.
have them here
Oh.
in pencil,
Okay.
right? And I have this one right here in pencil.
Yeah. So
Okay.
only one half of the line is going to be perpendicular. That is what you're saying.
I don't think so. I think just a second before you
No,
answer the
no,
question.
I
I
mean,
might
like-
have drawn those wrong.
No, I got the same thing. I think. Yeah, I did. I got the same thing.
I think it's no. I have these wrong. My bad. Just a second. That's not true. That is the circumcenter. Excuse me. That is the in-center. And if I took that point and come straight down, so that it is perpendicular to the side, then it's equidistant. So, and it's gonna be the points where these touch, and it's not necessarily. Yeah. Oh, okay. My bad. It is equidistant to the sides, but it's the shortest distance to that side. These now, it's where it meets the edge of that circle is that distance. Okay, this is going to be the hardest of all the constructions that you'll do to find that inscribed circle. Excuse me. Okay. Yes, ma'am.
So the dot is called.
The in-center. Yes, it is the center that is equidistant to all the sides.
So are those still technically the other lines, or did you? Just...
No, these are the lines that help you find the in-center. But this distance that I draw, these red ones right here, that is the radius of that circle.
So the red lines aren't the same as this.
Pencil lines. That is correct. Those pencils.
Okay.
Don't stress.
Just draw it.
We'll do some constructions to help you get them. Okay. So don't
What do I
stress.
need to draw on this?
What you need to know right now, for that on yours, is that is the point of concurrency, and it's called the in-center. So that point that you have right there is called the in-center. That's what you need to remember. Okay, it's the center of the inscribed circle. We have in-center. Okay. And you glued it to the back of your yellow page already. Let's go to this. Go to the front side. You have an extra triangle right there. You can glue it on in. If for some reason I didn't cut it small enough, then we can scoot it over a little or turn it to its side or so. And we're going to fill in the notes that goes with this. We're doing really good on time. Okay. How did we create that in-center? What was it created by?
Angle bisectors.
Angle bisectors, that is correct. So you had, by the way, your little triangle up here.
So same thing as the other thing in the creative box? Or?
No, that's perpendicular bisectors in the other one.
This was created by
Angle bisectors.
angle bisectors, so
Oh, I
angle
thought it said-
bisectors.
Okay.
Your in-center is created by your angle bisectors. So it's then this important fact is the same as your postulates and theorems that go with it. The in-center of a triangle, and this is what number for your
10.
inscribed, it's called your in-center theorem.
Oh wait, in-center thing?
So your in-center of a triangle theorem, your in-center theorem says the in-center of a triangle is
Equidistant.
from the sides. All right, now I gave you a little thing a trick to help you remember this. Last time, this was backwards. Last time, this little thing said, if you bisect the sides, it's equidistant from the angles. So this time, if you bisect the angles, it's equidistant from the sides. The trick is remembering that that bisecting the angles goes with in-center and bisecting the sides goes with circumcenter. Okay? We're going to have 3 different kind of centers for our triangle. Right? You were saying, isn't that just the center of the triangle? Yes, but there are different ways to calculate that center. You can come from the equidistant from all the vertices, find that point, which was the circumcenter. You could find the point that's equidistant from the sides, that's the in-center. Then we'll have 2 more next week. Okay. All right, let's do some homework together. We're going to do number 1. Each figure shows a triangle with its 3 angle bisectors intersecting at P.
Just a minute.
Let's sit down with you guys. All right. If the angle bisectors intersect at P, what is P called? The circumcenter or the in-center? You're welcome to.
Circumcenter.
Number 1,
This is circumcenter.
it says that angle bisectors intersect at P. Is that the in-center or the circumcenter?
Circumcenter.
You sure? Is that what it says?
Wait.
Wait.
Angle bisectors.
Angle bisector.
In center.
Oh,
Oh, you said
angle
in.
bisector. It's gonna be in center.
Yeah, so and that little yellow thing is going to be very useful. Keep it in. Okay, so the angle bisectors, that means that P is the in-center.
Wait, so if these are all angle bisector,
Yes. So does that mean it's equidistant from where? What's equal on this page? I mean on this diagram. Is it equidistant to the angles or equidistant from the sides?
Equidistant to the sides.
Because remember, we bisected the angles, so then it's the sides, right? Okay. So it's equidistant. So what is equidistant here then? What letters go with what?
PX
PX is the same length as PY and PZ. Okay, so those are the things that are equal.
So we just put tick marks on them.
That's what I'm doing right now, just so we can get an idea what we have to do. Now let's answer the question. The question says to find PX.
If PY equals 8, so PX.
So this is 8 right here. 8 is PY. So what's PX?
if they're congruent, then it's gonna be 8.
That's
8.
correct. PX is 8. Yes. All right. That first stuff that I was doing with you was just reviewing vocabulary because the math part really wasn't hard to know that it was 8, but knowing what they're even asking me to find is the hard part. Okay, number 4 is what we're jumping to next because numbers 2 and 3 are the same as number 1. All right, so
Wow.
resist the temptation now to do that problem 2 and 3. Jump to number 4 for me, Amy, would you?
I was doing the same thing.
All right, resist the temptation. We're still doing angle bisectors, okay?
I know, right?
So it's still equidistant from the sides. It's asking us to find the length of PW. I'm going to just mark that in red. If AW is 8 and AP is 10.
Huh?
This is something you might not have remembered how to do from a while ago.
What?
So,
Oh! Wait.
What is it? What is it? What is it? What kind of triangle is that? And how do we find it?
I remember doing this, but I can't remember. Wait.
What kind of triangle is that I've
It's a
drawn?
right triangle.
It's a right
It's a right-
triangle, correct? If you know, there is a formula that we haven't covered this year. That's why we're doing this together.
I'm gonna go ahead.
For the lengths of the side of a triangle, if I'm going to draw it differently, I'm going to draw it exactly like that one. If I know this one's A and this is
Isn't it just
B, and
1/2
this
base
is,
times height?
no, that's for an area. How do I find the lengths of the
Isn't it,
sides if you know?
10? Isn't it 10 plus 8 plus 90 equals 1?
That's only if
No,
it's the
that's-
inside.
that's the-
If I said something like the Pythagorean theorem, does anybody bring any remembrances of back in the day when you were doing this? in
I
algebra?
remember.
A squared plus B squared equals C
A
squared?
squared plus B squared. That's why we're doing this together. Equals C squared because this is something you have to have review
Yeah,
for because
okay.
it's back in when you were in algebra. All right, we're looking for
Now I see why they say it.
this. I'm not going to call it X. I'm going to call it A. If you want to call it B, that would be fine also.
So,
On this formula, A and B are the legs. C must be the hypotenuse.
Why?
That's how the formula works.
Oh. Okay.
Okay? That's the way I can say that's the way God made it.
wait, so it's gonna be.
All right, it's thought that even the Egyptians used this to make sure that the pyramids were exactly square at the corners when they were building them. Okay? That means that since the pyramids were built before even Abraham was there, that the Pythagorean theorem was known even during Jesus' time. Okay?
And
All
I
right.
did this wrong.
I'm going to back up a little, take some of these things off. All right, so we're going to plug in. I'm looking for A. I'm going to write A squared. B is the other leg, which is 8. I'm going to do 8 squared.
Oh yeah, the.
And the hypotenuse, which is that longest one, is 10. So I'm going to do 10 squared. Okay?
Oh. Got it.
What does squared mean?
Times itself.
Very good. So I'm going to have A squared plus 64 equals 10 squared, which is 100. How do I solve this?
Move the 64.
Move the 64 over.
And then take the square root.
A squared, somebody help me. What's 100 minus 64?
100 minus 64. Oh yeah, that's
20.
36.
36. All right. I'm going to stop there because I'm going a little fast.
I think I'm caught.
This question right here says, what times itself gives us 36?
6.
6. If you didn't know that, but you can take the square root of it on your calculator, and A equals 6. A is not what we're looking for. I mean, A is what we're looking for, but they're calling it PW. Okay. So numbers 4, 5, and 6, you're going to have to use the Pythagorean theorem.
Oh yeah. I forgot.
Make sure you. If I were you, I would draw that little triangle out and put the numbers right next to it, so you know if they're giving you the hypotenuse or they're giving you one of the other legs. They could give you the length of a hypotenuse. Okay.
Okay, so when we're doing this, instead of circling it as A equals 6, we would do.
It's really PW, which is the
PW.
same as A. You can call it. It's the same.
Oh, okay.
It's the same.
The answer key doesn't say that anyway.
It does just 6.
True.
Yeah.
It'll just say 6.
All right. Questions? All right. Now I'm gonna pause this video. We're gonna do numbers 17 through 19 odd all together. They are all constructions. It will not be videoed. Okay. So what you will not see 7 through 19 again on the video on YouTube. Okay.
Wait,
So you'll want to
19.
pay close attention right here
17.
as we do it.
Oh, 7 through 19.
7 through 19, all of those together, odd. We're going to do those together, okay? All right. All right. We learned what is true about the perpendicular bisectors of a triangle, that they're equidistant from the vertices, and they meet at the circumcenter. We also learned what is true about the angle bisector of a triangle. We learned that they're equidistant from the sides, and they meet at the incenter. Have a wonderful day. Bye-bye.